The Department of Material Science and Engineering at the University of Maryland is a relatively small department in the college, but has a large impact in the areas of research that we're pushing forward. We have some very exciting programs going on. For example, the areas of materials for energy and the areas of materials for nanotechnology.
My work is on ion-conducting materials. They're used in fuel cells, in batteries, in a whole variety of different energy-related applications. Specifically, most of the work is on solid oxide fuel cells, and they're a way of generating electric power from a variety of fuel sources, from hydrogen to natural gas to gasoline and biofuel. It really is a unique technology that has transformative properties for all aspects of energy production.
It's nice to imagine that 10, 15, 20 years from now, some of the work that I'm doing now could actually be used in something that will become a daily activity, like driving or even standalone solid oxide fuel cells for grid usage. That's an exciting prospect to be able to be like, oh yeah, I helped with this.
The interest in electrical energy storage is to solve big societal problems, because we can't deal with the variability of renewable sources if we can't store that energy and then have it available when it's used. That's why our research is funded by the Department of Energy's Energy Frontier Research Program. Our focus in that program is on making nanoscale structures which are specifically good to store charge, and that's how you save electricity in a battery.
My research project is focused on using atomic layer deposition, which is one of the hallmarks of Dr. Rubloff's research groups, as a technique to fabricate a new lithium-air thin film battery, which should have much higher theoretical capabilities than currently available battery technologies.
The world of energy storage believes that nanostructures are the ultimate answer for a next generation of technology. So we're laying the scientific fundamentals to be able to make that a reality.
What we do is we use electron microscopy to study carbon nanotubes and how heat flows through them. And this has possible applications in information technology, because nanotubes can behave as semiconductors, just like silicon, and they can also pass current. And so in principle, you could pack more nanotubes together and have them operating at faster speeds than you could with silicon transistors. The instrumentation we have here is world-class. This electron microscope is unique in the world in terms of its capabilities for being able to look at nanoscale structures in real time and see what they're doing.
We're developing the use of atomic layer deposition as a means of protecting heritage metals. And so the idea is to come up with a technique that allows us to apply a protective coating quickly without changing the appearance, and in a manner that we can remove that film later on if we choose to, without affecting the underlying art object.
This work is at the intersection of material science and art conservation. So it's really exciting, since we have the potential with this project to really change the field and change the current practices of silver preservation.
In my laboratory, we dedicate ourselves to discovering new materials. And we do this high throughput, what we call the combinatorial approach, where traditionally materials have always been discovered in a one-by-one trial and error method. We do it in such a way so that you can make hundreds to thousands of all different compositions all at once and rapidly screen them.
Our faculty are both at the cutting edge of research and creation of new knowledge in the field of material science and engineering, and then they're fully engaged with the students in the classroom, exciting them about the things that are happening in the field of material science and engineering and the things that are happening in the world that require new materials and solving of some of the great problems that we're dealing with as a society.
Technology we're developing will give us the next iPod, it'll give us the more efficient technology that everyone wants. I hope you'll have some of my technology on your desk in the next, within our lifetime, let's say that.